Hello and welcome. You will now learn about Amazon CloudWatch. Amazon CloudWatch is a monitoring and management service. It provides you with data collection and presentation dashboards to give you visibility into what is happening with your AWS compute resources, like EC2 instances, containers, Lambda functions, and many others. Resource monitoring helps you detect and respond to major changes in utilization so that you can get a unified view of and optimize operational health. CloudWatch collects operational data in the form of metrics, logs, and events. You can also use CloudWatch to set alarms. An alarm defines what type of usage constitutes a problem so that you can take corrective action. You can also use CloudWatch to collect and visualize logs into dashboards. This is going to help you discover and troubleshoot issues. It also gives you the information you need to optimize your applications. CloudWatch verifies that things are running smoothly by giving you visibility into what is happening in your AWS implementation. Three main features that CloudWatch supports are CloudWatch Monitoring, CloudWatch Logs, and CloudWatch Events. You will explore each of these three functional areas in this module. Amazon CloudWatch integrates with more than 70 AWS services that automatically publish detailed standard metrics without any action on your part. You can use these metrics to monitor most of the resources you deployed on AWS. For example, Amazon EC2 instances automatically publish metrics like CPU usage, data transfer, and disk usage to give you visibility into any major changes in state. You can also monitor resource utilization, such as disk activity for managed databases like Amazon RDS instances. Amazon CloudWatch can also be used to monitor an AWS Lambda deployment. You can use one of 8 built-in metrics for Lambda functions to detect errors or throttles. Above and beyond standard metrics, you can also collect custom metrics to monitor your own applications and improve operational performance. For example, if you're running an HTTP server on an EC2 instance, you can configure a CloudWatch agent to collect and publish statistics on memory usage of that HTTP service. User activity is another example of a custom metric you can collect and monitor over time. The CloudWatch agent enables you to collect system-level metrics from EC2 instances, other AWS compute resources, and also servers in your own facilities. You can configure CloudWatch alarms that trigger when a specific condition is met. For example, if the CPU utilization of an EC2 instance exceeds 80% over a 5-minute period. CloudWatch alarms can publish notifications using Amazon Simple Notification Service, also known as Amazon SNS. It can also publish to Amazon Simple Queue Service, also known as Amazon SQS. These notifications can be sent to alert people that a particular condition is met and needs intervention. Other notifications could be monitored by a script or an application that automatically implements the corrective measures. This could be as simple as restarting an EC2 instance that becomes unresponsive. In this diagram, you see CloudWatch monitoring in action. We see that an EC2 instance has a CloudWatch agent installed on it, and detailed monitoring is enabled. The first metric is CPU utilization. This is a standard metric in CloudWatch and is collected automatically. Memory utilization on an EC2 instance is not visible at the hypervisor layer and is not a standard metric. The CloudWatch agent is configured for a custom metric to monitor the memory utilization of the HTTP service. A CloudWatch alarm is configured to trigger when CPU utilization exceeds some predefined value. When the alarm is triggered, CloudWatch sends a message through Amazon SNS, which generates an email notification. A third-party paging or tracking system receives the alert. This alert will likely trigger other actions, such as paging the on-call support staff. Meanwhile, the same CloudWatch alarm also sends a message to an Amazon SQS queue, which generates a work item. Metrics are a fundamental concept in CloudWatch. A metrics represents a data point published over time. Think of a metrics as a resource to monitor. The data points represent the use values of that resource over time and can come from any application or any system. Metrics are uniquely defined by name, a namespace, and 0 or more dimensions. Each data point has a timestamp, and optionally, a unit of measure. When you request statistics, you get a data stream identified by namespace, metric name, dimension, and optionally the unit. Metrics exist only in the region where they are created. A namespace is a group of CloudWatch metrics. Metrics in different namespaces are isolated from each other. This way, metrics from different applications are not mistakenly aggregated into the same statistics. The AWS namespaces use the naming convention of AWS/service. For example, Amazon EC2 uses AWS/EC2 namespace. A dimension is a name-value pair that uniquely identifies a metric. You can assign up to 10 dimensions to a metric. Each metric has specific properties that describe it. You can think of dimensions as categories for those properties. Dimensions help you design a structure for your statistic plan. You can use dimensions to filter the CloudWatch data. For example, when you search for metrics, you can get statistics on a specific EC2 instance by specifying the dimension of instance ID. A period is the length of time associated with a specific CloudWatch statistic. Periods are defined in numbers of seconds. You can adjust how the data is aggregated by varying the length of that period. A period can be as short as 1 second or as long as 1 day. Here's an example. This is the result generated by asking CloudWatch to list the metrics available for the namespace AWS S3 via the command line interface. Notice from this result that the metric name indicates the data point being collected. In this case, the size in bytes. The dimensions specify the specific resources that will be used to obtain the metric. In this case, it's a single bucket called My Bucket, and this bucket is of type Glacier Storage. Finally, the namespace specifies the service where the resources live. The result in this example indicates that there seems to be only one bucket defined in the account's S3 service. The standard metric bucket size bytes is listed for each resource available in S3. As mentioned before, CloudWatch has both standard metrics and custom metrics. Standard metrics are grouped by service. For example, if you open the AWS Management Console and go to the CloudWatch service screen, you can click a link to view all Amazon EC2 instance metrics available. Metrics cannot be deleted. However, they automatically expire after 15 months if no new data is published to them. Data points that are older than 15 months expire on a rolling basis. As new data points come in, data that is older than 15 months is dropped. AWS services send metrics to CloudWatch. You can publish your own metrics to CloudWatch by using the AWS CLI, the API, or the CloudWatch agent. One common use of Amazon CloudWatch is to monitor account resources for suspicious activity. For example, generating alerts based on billing data is a good way to detect potential security violations of your AWS account. Some customers learn that their credentials or their access keys were compromised only when they receive a bill for unexpected charges. To detect this proactively, you enable billing alerts in your account preferences. You then set CloudWatch alarms to alert you if estimated billing charges exceed a specified threshold. You can create a CloudWatch alarm by defining what constitutes a problem using a threshold value over a time period. We already use an example of CPU utilization being greater than 80% over 5 minutes. In this case, we can use an expression that evaluates a single CloudWatch metric, that of CPU utilization. You can also use an expression based on multiple metrics. Alarms have 3 possible states. The OK state means the threshold is not exceeded. The alarm state means that the threshold was exceeded. And the insufficient data state means that not enough info is available to provide a meaningful result. The alarm performs one or more actions based on the value of the expression of the threshold defined over time. Note that sometimes an alarm state for a resource does not constitute an emergency. For example, when you're starting or shutting down a system, some alarms may trigger because the system is not in a steady state. These are called false positive alarms. In the diagram, the CloudWatch alarm threshold is set to 3, and the minimum breach is 3 periods. The alarm invokes its action when the threshold is breached for 3 consecutive periods. In this diagram, this situation happens between the 3rd and 5th time periods. In the alarm state, it actually gets set to alarm at the time period 6. The value drops below the threshold and the state reverts to OK. Later, during the 9th time period, the threshold is breached again, but not for the necessary 3 consecutive periods. As a result, the alarm state remains OK. For more information about creating CloudWatch alarms, search for CloudWatch alarms in the AWS documentation. Amazon CloudWatch dashboards are customizable home pages in the CloudWatch console. You can use dashboards to monitor your resources in a single view. You can get aggregated views of the health and performance of all AWS resources through CloudWatch automatic dashboards. You can use automatic dashboards to monitor account resource metrics, including alarms. Automatic dashboards are pre-built with recommended best practices for AWS services. They remain resource-aware and dynamically update to reflect the latest state, important performance metrics. In the example, the upper left area of the screen shows a list of AWS services that are being used in this account. This also shows the state of the alarms that are configured for those services. The upper right area shows any recent alarms that have triggered. The number of alarms that display here depend on whether the alarms were both configured and triggered. The lower part of the dashboard optionally enables you to add metrics of your own custom services or applications to the overview page. You can also bring additional key metrics from AWS services that you want to monitor the most. By default, the bottom part of the automatic dashboard shows the title Cross-Service Dashboard Metrics. However, there is a link to create a new CloudWatch default dashboard. If you name the new dashboard CloudWatch Default, it displays on the main CloudWatch overview page. By default, EC2 instances are enabled for basic CloudWatch monitoring. EC2 data is available in 5-minute increments as part of the AWS free tier. However, you can also enable detailed monitoring at an additional cost. After detailed monitoring is enabled, the monitoring data becomes available in 1-minute increments. For more information about detailed monitoring, search for CloudWatch in the AWS documentation. To learn more about the AWS free tier, search for free tier on the AWS homepage. This completes the CloudWatch discussion about monitoring. Thanks for watching. Hello and welcome. You will now learn about CloudWatch events and CloudWatch logs. CloudWatch events delivers a near real-time stream of system events that describe changes in AWS resources. You can configure simple rules to match events and route them to one or more target functions or streams. CloudWatch events becomes aware of operational changes as they occur. They respond to these operational changes by sending messages, activating functions, making changes, and capturing state information. You can schedule automatic actions that self-trigger at certain times using cron or rate expressions. For details about creating schedule expressions that use rate or cron, search for tutorial schedule events in the AWS documentation. Before you use CloudWatch events, it's important to clarify the following concepts. An event indicates a change in your AWS environment. AWS resources can generate events when their state changes. For example, Amazon EC2 generates an event when the state of an EC2 instance changes from pending to running. You can generate custom application level events and publish them to CloudWatch events. You can also set up schedule events that are generated on a periodic basis. A target processes the events. Example targets include EC2 instances, Lambda functions, SNS topics, and SQS queues. A rule matches incoming events and routes them to targets for processing. A single rule can route to multiple targets, all of which are processed in parallel. This enables different parts of an organization to look and process the events that are of interest to them. In the example, a CloudWatch event rule is being created. Here, an AWS Systems Manager run command script is run on the instance every time a new instance is created. We previously discussed CloudWatch monitoring and CloudWatch events, but what about log processing? As shown here, you can think of the process of log analysis as having 3 separate phases. First, you must decide on the information you must capture in your logs, and where and how the data will be stored. Next, you need a strategy for periodically uploading a server's log files so that you don't lose this valuable information when an instance is eventually terminated. After all the data is collected, it's time to analyze. Using log data gives you greater visibility into the daily health of your systems. It can also provide information about upcoming trends and customer behavior. You can also get insights into how customers currently use your system. You can use CloudWatch logs to monitor, store, and access your log files from EC2 instances, CloudTrail, Amazon Route 53, and many others. You can then retrieve the associated log data from your CloudWatch logs. You can monitor your logs in near real time for specific phrases, values, or patterns. For example, you could set an alarm on the number of errors that occur in the system logs on one or more EC2 instances. You can view graphs that visualize the latency of web requests from your application logs on your EC2 instances. You can then view the original log data to see the source of the problem. You don't have to worry about filling up hard drives with your log data. You can store and access your CloudWatch logs indefinitely. You can also store log data externally to EC2 instances. CloudWatch Logs enables you to automatically collect logs from one or more of the supported AWS services, such as Amazon EC2. You must install the new unified CloudWatch agent or the older CloudWatch Logs agent on any EC2 instance that you want to collect log data from. You can then aggregate data from a number of different EC2 instances into what is known as a log group. Each log group should represent a specific type of log with a set format. The CloudWatch agent gathers data from the log that you specify, like an application log, and sends it to the appropriate log group. Then you can create filters on a log group to look for specific strings or string patterns. Each match assigns a numeric value, which is then used to increment a custom CloudWatch metric. Like any other custom CloudWatch metric, you can use that metric to create CloudWatch alarms or send notifications. CloudWatch Logs Insights is a part of the CloudWatch service that provides a purpose-built query language with a few simple but powerful commands. It provides sample queries, command descriptions, automatic completion for queries, and log field discovery to help you get started quickly. Sample queries are included for several types of AWS service logs. The diagram shows the workflow for a CloudWatch alarm. First, a log group named HTTP access log contains aggregated log data that is collected by the CloudWatch agents installed in one or more EC2 instances. Then, an administrator creates a custom CloudWatch filter on the log group to search the log for 404 page not found HTTP error messages. Each match increments a custom CloudWatch metric for the 404 account. The administrator can use that metric to trigger a CloudWatch alarm anytime the 404 account exceeds a specified value. When the CloudWatch alarm is triggered, it sends a notification. In this case, the notification goes to the IT support team. Application logs typically generate data in a standardized format. To successfully parse relevant data out of the log files, it's important to understand the log format. Log files generated by a Linux operating system have a whole different structure and information than log files from a web server. For web servers, you can define the structure of the log file. This is a convenience of the Apache web server environment. Other systems may have a fixed predefined structure for their log files. Here's an example access log file entry generated by the Apache web server application. It corresponds to the log format definition above it. Each time the web server receives an HTTP request, a new line with this format is created in the access log file. %H is the IP address of the host machine that made the HTTP request. %L is the identity of the client machine. This information is typically not available, and the dash character is the result that indicates that. %U is the user ID of the person requesting the information. If the website did not require a login, this information is not known. In the example, a user named Frank made the request. %T is the time that the request was received. %R is the request line. It includes what type of request was received, such as GET. It also includes what resource was requested, such as an HTML page, a graphic file, or a style sheet. %S is the HTTP status code that the web server responded. In the example result, the status code of 200 indicates a success. You may find other codes, such as 404, which means resource not found. %B, which is the last part, records the size of the object returned to the requesting client. The structure of the log file is important because for CloudWatch logs, to create a metric filter, you must define a filter pattern. You can have multiple terms in a metrics filter pattern, but all terms must appear in the log event to get a match. For example, if you have a filter pattern of error exception, it will match only the log entries that contain both the word error and exception. This example creates a metric for all results with the string HTML anywhere in the request and any number that starts with a 4 in the status code. The HTTP 400 type response status code indicates a bad request that the server cannot or will not process because of something that is perceived to be a client error, like a malformed request syntax, an invalid request message framing, or deceptive request routing. For details about the filter, search for filter and pattern syntax in the AWS documentation. This concludes the discussion of CloudWatch events and CloudWatch logs. Thanks for watching. Hello and welcome. In this segment, you will learn about AWS CloudTrail and AWS Config. You'll also learn how to use Amazon Athena to improve monitoring and security. AWS CloudTrail could have been called AWS Audit Trail because that's exactly what it does. AWS CloudTrail maintains a full detailed audit trail of all interactions sustained by AWS APIs. CloudTrail gives you visibility into the what, the who, the when, and the where of AWS API interactions. It becomes your baseline reference for audits and investigations. You can use AWS CloudTrail for governance, compliance, operational, and risk auditing of AWS accounts. CloudTrail supports logging events for many AWS services. After you configure CloudTrail, it pushes the auditing logs to Amazon S3. The scope of AWS CloudTrail is the service API interactions. This means that what happens inside an EC2 instance, it's outside the scope of CloudTrail visibility. For example, CloudTrail does not track when someone manually shuts down an instance if they connect to it via a secure shell and issue a shutdown command. CloudTrail enables you to know who did what, when, and where from. Security and auditing teams may want to know who changed a security group configuration. You may need to track activity that comes from an unknown IP address range because it could indicate a potential external attack. Knowing which activities were denied because the user didn't have permissions will allow you to improve security. When you access the CloudTrail event history, by default, you only see the results from the last 90 days. These events are limited to account activity and management events with create, modify, and delete API calls. You must change the default configuration if you want to see a complete record of account activity. You can create a trail by using the CloudTrail console or by using the AWS command line interface. The steps for creating a trail are listed here. First, you create an S3 bucket or specify an existing bucket where you want to store the log files. Then, configure your trail to log read-only, write-only, or all management and data events. By default, trails log all management events. Finally, create an SNS topic to receive notifications when log files are delivered. You also have the option to configure CloudWatch logs to receive CloudTrail logs so that you can monitor for specific events. Another option is to turn on log file encryption for added security. Finally, you can add tags, which are custom key value pair identifiers for your audit trail. CloudTrail log files are in JSON format. Each CloudTrail log file contains one or more entries. A log entry represents a single request from any source. It includes information about the request action and the response. Here is an example request parameters sections of a log entry. It has the typical data that will be included when someone logs into the console with user information that was created with AWS Identity and Access Management. Additional parameters can be included. The actual list of parameters depends on the type of action that was logged. Log entries are not guaranteed to be in any particular order. They are not an order stack trace of API calls. This example shows the response element section of the same sample log entry. Notice the extensive number of details that are recorded for each entry. In this case, the attempt to log into the console was successful. The user did not use the mobile version of the console and didn't use multi-factor authentication to log in. Here's another response element section. It shows that the login attempt was unsuccessful. Using CloudWatch and CloudTrail together to monitor activity in your account is a best practice. The features of these two services are complementary. With the combination of CloudTrail and CloudWatch log, you end up with a significant amount of log data stored in Amazon S3. You can quickly become a large-scale data set, and you can ask, how are you going to analyze all that data? Amazon Athena is an interactive query service that makes it easy to analyze data in Amazon S3 by using a standard structured query language. To use Athena, point to your data in S3, define the schema, and use standard SQL to query the data. Most results are delivered in seconds. With Athena, you don't need to use complex extract, transform, and load jobs to prepare your data for analysis. Athena makes it easy for anyone with SQL skills to quickly analyze large-scale datasets stored in S3. Athena works well for quick and ad hoc queries. It can also handle complex analysis, including large joins and arrays. Athena uses S3 as its underlying data store, which means it is highly available and durable. Here's the overall workflow for Athena. First, provide Athena with the location of your data in S3. Athena discovers the schema, and then you can start writing queries. You can either copy the results from the console or download them to a comma-separated values file. You can use Athena to query data generated from other AWS services. You can query application load balancer logs to see the source of traffic, latency, and bytes transfer to and from the load balance instances and backend applications. You can also query Amazon VPC flow logs to analyze the IP traffic going to and from interfaces in a VPC. For the full list of AWS services that integrate with Amazon Athena, search for Athena AWS service integrations in the AWS documentation. It is fairly common for a customer to run hundreds, if not thousands, of EC2 instances in their AWS accounts. Other resources on the AWS account might also exist in large numbers. It's a challenge to manage the configuration of all these resources. You might know what the current configuration of deployed resources should be. However, do you have visibility into possible configuration errors? Do you have a system to manage and tracking configuration changes? How can you implement versioning, history, and change management of your infrastructure? AWS Config allows you to assess, audit, and evaluate the configurations of your AWS resources. AWS Config continuously monitors and records your AWS resource configurations. It enables you to automate the evaluation of recorded configurations against desired result. You can retrieve an inventory of AWS resources with AWS Config. You can also record configuration changes so you can compare compliance with your internal guidelines. Finally, you can be notified when configurations change, and you can analyze resource configuration changes to allow or deny the change requested. You can set up AWS Config by creating rules. You can use existing rules from AWS, an AWS Partner Network member, or you can define your own. You can also define custom rules by using AWS Lambda. You can target rules to specific resources, to specific types of resources, or to resources with specific tags. Rules are run when those resources are created or changed. They can also be evaluated on a periodic basis, such as hourly or daily, to verify things are as you expect. You can set up rules to verify that any configuration change is recorded. After you set up AWS Config, it provides a dashboard for visualizing compliance and for identifying changes to your resources that might be of concern. AWS Config is invoked automatically so that configurations are constantly being assessed. Rules can look for any desirable or undesirable condition, and they can verify things are configured consistently and correctly. This concludes the discussion of AWS CloudTrail and AWS Config. Thanks for watching. It's time to review the module and wrap up with a discussion of a practice question for the certification exam. In summary, you learn about the benefits of CloudWatch, CloudTrail, and AWS Config. You learn how you can use these tools to monitor and secure your AWS implementation. You also learn how you can use Athena to analyze data captured in Amazon S3 by CloudTrail and other services. Great work! Now you will analyze a sample certification question. Review the sample scenario and find any keywords that will help you identify the correct answer. Here, the keywords in this scenario are highlighted. You can now consider the answer options. Keeping the keywords in mind, review the answer options and try to rule them out based on the highlighted keywords. The best solution in this case are start time, status, and version. Now, it's time to complete the Module 9 guided lab, monitoring your applications and infrastructure. You will also complete the Module 9 challenge lab, monitoring with AWS CloudTrail. This concludes the discussion about monitoring, management, and security. Thanks for watching.